Ask almost anyone to describe Saturn, and you'll probably hear the same answer: the planet with the rings. For centuries, those rings have made Saturn one of the most recognizable objects in the solar system. They've appeared in textbooks, science museums, movies, and countless photographs captured by telescopes and spacecraft. But here's the surprising part. The rings aren't what makes Saturn extraordinary. They're simply the first thing we notice. The deeper scientists have explored this giant planet, the stranger it has become. Saturn is a world where winds race faster than the speed of sound, where an enormous excited storm has remained locked above the North Pole for decades, where lightning flashes inside clouds thousands of kilometers thick, where the entire planet is so light that if an ocean large enough existed, it would actually float. And surrounding Saturn is an entire family of remarkable moons. Some hide oceans beneath frozen crusts. One has rivers, lakes, and rain. Another may be spraying the ingredients for life directly into space. Together, they form one of the most fascinating planetary systems we've ever discovered. Yet despite decades of exploration, Saturn continues to surprise us. Every new mission has answered old questions, only to uncover even greater mysteries. Today, we're traveling nearly 1.5 billion kilometers from Earth to explore a planet that has fascinated humanity for thousands of years, not because it's the most beautiful, but because it may be one of the most misunderstood worlds in our solar system. This is the story of Saturn. Long before telescopes existed, Saturn was already known to ancient civilizations. Unlike Uranus and Neptune, which are invisible to the naked eye, Saturn appears as a steady point of light, slowly moving against the background stars. Its motion distinguished it from ordinary stars. The ancient Babylonians carefully recorded its position. Greek astronomers included it among the 7 wandering objects visible in the night sky. The Romans eventually named it after Saturn, the god of agriculture and time. For thousands of years, that tiny golden dot was all humanity knew. No one could have imagined what was really waiting there. Everything changed in 1610. Galileo Galilei pointed one of the world's first astronomical telescopes toward Saturn. What he saw made almost no sense. Instead of appearing as a simple sphere, Saturn seemed to have 2 mysterious objects attached to its sides. Galileo described them as handles or ears. He couldn't explain them. His telescope simply wasn't powerful enough to reveal their true shape. Even stranger, a few years later, those mysterious structures appeared to vanish completely. Galileo believed Saturn had somehow changed. It hadn't. The rings had simply rotated to an angle where they became almost invisible from Earth's perspective. It would take decades before Dutch astronomer Christian Huygens finally solved the mystery. Saturn wasn't changing shape at all. It was surrounded by a thin, flat ring unlike anything ever observed around another planet. One of astronomy's oldest mysteries had finally been solved. But in reality, it was only the beginning. For centuries, Saturn's rings dominated almost every conversation about the planet. It was understandable. Nothing else in the solar system looked remotely similar. Yet, while people admired the rings, Saturn itself remained surprisingly mysterious. As telescopes improved, astronomers began noticing something unusual. Saturn wasn't a rocky world like Earth, nor was it simply a larger version of Mars. It belonged to an entirely different class of planet, a gas giant. Together with Jupiter, Uranus, and Neptune, Saturn represents one of the 4 giant planets that formed in the outer solar system more than 4.5 billion years ago. But even among the giants, Saturn stands apart. At first glance, Saturn seems enormous. Its diameter is more than 9 times wider than Earth's. You could line up about 760 Earths inside its volume. Yet despite its immense size, Saturn is surprisingly lightweight for a planet of its scale. Its average density is lower than water. That's one of the most famous facts about Saturn. It's also one of the most misunderstood. People often hear that Saturn would float if placed in a giant ocean. Technically, that's true, but only because its average density is about 0.69 grams per cubic centimeter, while water has a density of 1 gram per cubic centimeter. Of course, no ocean remotely large enough exists. The comparison simply reveals something remarkable about Saturn's composition. Unlike Earth, Saturn is made almost entirely of hydrogen and helium, the same elements that dominate the Sun. It isn't a giant ball of air. The pressure inside Saturn is so extreme that these gases behave in ways completely unfamiliar on Earth. As you descend deeper into the planet, hydrogen is compressed more and more until it begins transitioning into exotic forms of matter created only under enormous pressure. Saturn has no solid surface where a spacecraft could land. Instead, the atmosphere gradually becomes denser, hotter, and more compressed with depth. The deeper you go, the less meaningful the idea of a surface becomes. That atmosphere is one of the most dynamic environments in the solar system. From Earth, Saturn often appears calm. Its pale yellow clouds give a softer appearance than Jupiter, whose colorful storms are easy to spot even through small telescopes. But appearances can be deceiving. High above Saturn's cloud tops, winds regularly exceed 1,800 kilometers per hour, making them among the fastest planetary winds ever measured. These powerful jet streams circle the planet continuously, creating broad cloud bands that wrap around the globe. Unlike hurricanes on Earth, these atmospheric currents aren't driven by oceans or continents. They are powered by internal heat rising from deep within the planet. In fact, Saturn radiates more energy into space than it receives from the Sun. That means the planet is still releasing heat left over from its formation billions of years ago. Combined with the slow compression of hydrogen deeper inside the planet, this internal energy keeps Saturn's atmosphere in constant motion. The result is a world that is far more active than its peaceful appearance suggests. Occasionally, Saturn reminds astronomers just how powerful its atmosphere can become. Roughly once every few decades, the planet experiences an event known as a great white spot. These are enormous storms unlike anything seen on Earth. They can stretch across tens of thousands of kilometers and eventually wrap around the entire planet. When NASA's Cassini spacecraft observed one of these storms in 2010, scientists watched as turbulent clouds erupted upward from deep within Saturn's atmosphere. The disturbance generated powerful lightning, intense radio emissions, and massive atmospheric waves that continued spreading long after the initial eruption. Some lightning bolts inside Saturn's storms are believed to be thousands of times more energetic than those produced on Earth. Even after centuries of observation, scientists are still investigating exactly what triggers these rare planetary-scale tempests. Then there's the feature that continues to puzzle researchers more than almost anything else on Saturn: its North Pole. Unlike every hurricane ever observed on Earth, Saturn's polar vortex is surrounded by a nearly perfect hexagon, 6 straight sides, 6 sharp corners, stretching roughly 30,000 kilometers across, large enough for several Earths to fit inside. The hexagon isn't made of clouds arranged into a geometric shape. It's actually a massive atmospheric wave, created by powerful jet streams flowing around the pole. Laboratory experiments on Earth have even recreated similar hexagonal patterns by rotating fluids at different speeds. But seeing the same phenomenon on an entire planet remains extraordinary. The hexagon has persisted through changing seasons for decades. It rotates with the planet almost like a permanent landmark in an atmosphere where almost everything else is constantly moving. It's one of the clearest reminders that Saturn still has secrets we don't fully understand. By the early 2000s, Saturn was no longer just a planet with the rings. Thanks to orbiters, flybys, and decades of increasingly sophisticated observations, astronomers had uncovered a world of immense complexity. A planet powered from within. A planet where physics behaves on scales impossible to reproduce on Earth. A planet whose atmosphere continues to challenge our understanding of fluid dynamics, weather, and planetary evolution. And yet, everything we've explored so far has focused on Saturn itself. The feature that first captured humanity's imagination still waits just beyond those clouds. Because surrounding the planet is a structure so vast, so delicate, and so dynamic that for centuries we barely understood what we were actually looking at. The story of Saturn's rings is far more extraordinary than anyone first imagined. If Saturn had no rings, it would still be one of the most fascinating planets in the solar system. But it does have rings, and they completely change the way humanity sees this giant world. For centuries, they were treated as little more than decoration, beautiful, unique, easy to recognize. Yet the closer scientists looked, the more they realized the rings are not simply surrounding Saturn. They're constantly changing, moving, colliding, reshaping themselves every second. Far from being a static structure, Saturn's rings form one of the most active environments in the solar system. From a distance, the rings appear smooth and solid. It's an illusion. In reality, they are made of countless individual pieces orbiting Saturn independently. Some are no larger than grains of dust. Others are the size of houses. A few are even comparable to mountains. Together, they create a disk stretching nearly 300,000 kilometers across. Yet despite this enormous width, most of the rings are astonishingly thin. In many places, they're only tens of meters thick. If Saturn's rings were scaled up to the size of a football field, their thickness would be less than a sheet of paper. That contrast is one of the reasons they appear so delicate. They're incredibly wide, yet unbelievably thin. Most of these particles consist of water ice. That's why Saturn's rings shine so brilliantly compared to those of Jupiter, Uranus, or Neptune. Fresh ice reflects sunlight extremely well. Some pieces are coated with darker material collected from tiny meteorite impacts over millions of years. Others remain remarkably bright, suggesting that collisions constantly expose cleaner ice beneath the surface. Every orbit brings new impacts. Tiny fragments collide, bounce apart, break into smaller pieces, or slowly merge into larger ones. The rings are not frozen in time. They're constantly evolving. The rings are traditionally divided into several major sections: the A ring, the B ring, the C ring, along with fainter outer rings such as the D, E, F, and G rings. These names don't represent the order in which they formed. They simply reflect the order in which early astronomers identified them. At first glance, these rings appear neatly separated. In reality, they're connected through a complex network of gravitational interactions. Some regions are densely packed. Others contain surprisingly empty gaps. Those gaps are not accidents. Many are carved by Saturn's own moons. One of the best examples is the Cassini division. When viewed through a telescope, it looks like an empty space separating Saturn's two brightest rings. For centuries, astronomers assumed very little existed there. Modern spacecraft revealed a different picture. The Cassini division isn't truly empty. It still contains countless particles. They're simply spread much farther apart than in the neighboring rings. The reason is gravity. Every time certain ring particles complete their orbits, they experience repeated gravitational tugs from Saturn's moon Mimas. Over millions of years, those repeated nudges gradually push many particles away, leaving behind the broad gap we observe today. It's one of the clearest demonstrations that gravity can sculpt entire planetary systems without ever making direct contact. Some moons do even more than create gaps. They actively shape the rings themselves. These small bodies are known as shepherd moons. The name is surprisingly appropriate. Just as a shepherd keeps a flock together, these moons use gravity to confine ring particles into remarkably narrow bands. Without them, some of Saturn's most beautiful rings would slowly spread outward and lose their sharp edges. The tiny moons Prometheus and Pandora perform exactly this role around the narrow F ring. As they orbit Saturn, their gravity continuously pulls and redirects nearby particles. The result is a ring that appears braided, twisted, and constantly changing. It's less like a solid structure and more like a flowing river responding to invisible currents. NASA's Cassini spacecraft transformed our understanding of these rings more than any mission before it. Arriving at Saturn in 2004, Cassini spent over 13 years exploring the planet and its moons. Instead of seeing the rings as simple bands of ice, Cassini revealed an astonishing level of detail: towering waves, ripple-like patterns, temporary clumps, spiral structures. Some waves stretch for hundreds of kilometers, created by the gravitational influence of distant moons. Others formed after tiny impacts disturbed the surrounding particles. Every image showed a system in motion. Nothing remained perfectly still. The rings behaved less like a solid object and more like a living laboratory where gravity could be observed in real time. One of Cassini's most surprising discoveries came from a place no one expected: the space between Saturn and its innermost ring. before the mission ended, engineers made a bold decision. Instead of keeping the spacecraft safely outside the rings, they directed it to the narrow gap, separating the planet from the ring system. No spacecraft had ever attempted such a maneuver. There was genuine concern that unseen debris might destroy the probe. Cassini survived, and what it found surprised everyone. The gap contained far less dust than scientists had predicted. Those final dives allowed Cassini to measure Saturn's gravity with extraordinary precision, helping researchers estimate the total mass of the rings more accurately than ever before. That number turned out to be incredibly important because it offered new clues about the rings' age. For generations, many astronomers assumed Saturn's rings formed alongside the planet more than 4.5 billion years ago. It seemed like the simplest explanation. Then Cassini's measurements challenged that idea. The rings appeared cleaner, brighter, and significantly less massive than expected. If they had existed since the birth of the solar system, billions of years of dust from comets and micrometeorites should have darkened them considerably. Instead, they still look surprisingly young. Some researchers now estimate that Saturn's main rings may have formed only 100 to 400 million years ago. If that's correct, the dinosaurs had already disappeared from Earth before Saturn acquired the magnificent rings we see today. Not every scientist agrees. Some models still support a much older origin. Others suggest the rings may have been renewed over time through repeated collisions. The debate continues. But one thing is clear. Saturn's rings may not be ancient relics. They may be relatively recent features in the history of the solar system. As remarkable as that possibility is, another discovery may be even more surprising. Saturn's rings are disappearing, very slowly, but continuously. Powerful interactions between sunlight, Saturn's magnetic field, and tiny charged particles gradually pull ring material toward the planet. Scientists call this process ring rain. Microscopic particles spiral inward before falling into Saturn's upper atmosphere. Over immense stretches of time, the planet is literally absorbing its own rings. The process is incredibly slow on a human timescale. No one watching Saturn today would notice a difference. But over hundreds of millions of years, the loss becomes significant. Current estimates suggest the rings may continue fading until one day they largely disappear altogether. The planet that has defined itself through its rings may not keep them forever. That realization changes the way we see Saturn. Humanity exists during an extraordinarily fortunate moment. Billions of years ago, these spectacular rings may not have looked the way they do today. Billions of years from now, they may no longer exist at all. Our civilization happens to live during the brief chapter when Saturn wears the brilliant icy rings that have inspired generations of astronomers. It's a reminder that even the most iconic sights in the solar system are temporary. Nothing in the universe remains unchanged forever. Yet even Saturn's rings don't tell the whole story. Orbiting beyond them is an extraordinary collection of worlds. Frozen moons, ocean moons, a moon wrapped in a thick atmosphere, a moon that may be spraying water from an underground sea into space. Together, they transform Saturn from a single planet into one of the richest planetary systems ever discovered. And some scientists believe the greatest chance of finding life in Saturn's neighborhood isn't on the planet itself, but on the worlds that orbit around it. When the Cassini spacecraft arrived at Saturn in 2004, its primary mission was to study the planet and its magnificent rings. But as the years passed, something unexpected happened. Again and again, it was Saturn's moons that stole the spotlight. One after another, they challenged long-held assumptions about where oceans could exist, where chemistry could become complex, and where life might someday be found. By the end of the mission, Saturn no longer looked like a single planet. It looked like an entire planetary system. Today, Saturn is known to have more confirmed moons than any other planet in the solar system. Some are tiny objects only a few kilometers across. Others are larger than planets, once considered full-fledged members of our solar system. Each follows its own orbit. Each tells a different story. Some formed alongside Saturn billions of years ago. Others may be captured objects from the distant outer solar system. Together, they create one of the most diverse collections of worlds we've ever discovered. Among them all, One moon stands above the rest. Titan. At first glance, Titan doesn't seem particularly unusual. Its thick orange haze hides everything beneath it. For centuries, astronomers couldn't even see its surface. It wasn't until spacecraft flew close enough that the mystery began to unfold. Titan isn't just another moon. It's the only moon in the solar system with a dense atmosphere. In fact, its atmospheric pressure at the surface is greater than Earth's. Instead of nitrogen and oxygen, however, Titan's atmosphere is dominated by nitrogen mixed with methane and other hydrocarbons. Those ingredients create a world unlike any we've ever explored. When the European-built Huygens probe descended through Titan's atmosphere in January 2005, humanity saw something astonishing. The landscape looked strangely familiar. There were valleys, river channels, shorelines, smooth plains shaped by flowing liquid. For a brief moment, it almost looked like Earth, but appearances can be misleading. The rivers weren't made of water. Neither were the lakes. On Titan, temperatures average around minus 179 degrees Celsius. Water is frozen as hard as rock. Instead, methane and ethane take on the role that water plays on Earth. They evaporate into clouds. They fall as rain. They carve rivers. They fill lakes and seas. Titan has its own weather cycle, just with completely different liquids. It's the only other known world where stable liquid exists on the surface. Yet Titan's greatest mystery may lie beneath that frozen crust. Measurements from Cassini suggest a vast global ocean of liquid water may exist deep underground, protected beneath layers of ice. This hidden ocean could contain more water than all of Earth's oceans combined. No one knows whether it contains the chemistry necessary for life. But wherever liquid water exists, scientists pay attention. Titan reminds us that habitable environments don't always look habitable from the outside. Then there's another moon, much smaller, much brighter, and perhaps even more surprising. Enceladus, at only about 500 kilometers across, Enceladus was once considered little more than an ordinary frozen moon. Cassini completely changed that perception. As the spacecraft repeatedly flew past its south pole, instruments detected enormous plumes erupting into space. Water vapor, ice particles, organic molecules, tiny grains of silica. The moon was literally spraying material from its interior directly into space. It was one of the most extraordinary discoveries in planetary exploration. Scientists soon realized those plumes weren't random. They originated from long fractures near the South Pole known as tiger stripes. Beneath them lies a global ocean kept liquid by tidal heating. Every orbit around Saturn gently flexes the moon's interior. That constant stretching generates heat, preventing the ocean from freezing solid despite the extreme cold of space. The process works much like bending a paper clip over and over until it becomes warm, except in this case, the forces are generated by gravity itself. Cassini did something remarkable. Instead of drilling through kilometers of ice, it simply flew through the plumes. As it passed, the spacecraft sampled material that had erupted naturally from Enceladus' hidden ocean. The results were extraordinary. Scientists detected complex organic molecules, hydrogen, carbon compounds, and evidence suggesting hydrothermal activity on the ocean floor. On Earth, hydrothermal vents teem with life despite never receiving sunlight. That comparison immediately transformed Enceladus into one of the most promising places to search for extraterrestrial life within our own solar system. No one claims life exists there, but all three essential ingredients appear to be present: liquid water, a source of energy, and organic chemistry. Few places beyond Earth can currently make that claim. Saturn's other moons each add another piece to the story. Iapetus looks as though someone painted one hemisphere black, while leaving the other bright white. Scientists believe dark dust from the outer solar system gradually accumulated on one side, changing the moon's appearance over millions of years. Mimas, famous for resembling the fictional Death Star because of its enormous impact crater, was once considered completely inactive. Recent observations now suggest it may also conceal a subsurface ocean. Even one of Saturn's most familiar moons continues to surprise astronomers. Phoebe tells yet another story. Unlike most large moons orbiting Saturn, Phoebe travels in the opposite direction. Its unusual orbit suggests it wasn't born alongside Saturn at all. Instead, it was likely captured billions of years ago from the distant Kuiper Belt. Every moon preserves a different chapter of solar system history. Together, they reveal how dynamic Saturn's neighborhood has always been. When scientists compare the giant planets today, Saturn occupies a unique position. Jupiter is larger. Its gravity dominates the solar system. But Saturn offers something different. It combines a spectacular ring system with an extraordinary family of moons, many of which have become prime targets in humanity's search for life beyond Earth. In many ways, Saturn has become a natural laboratory for planetary science. Here, researchers can study atmospheres, gravity, ring dynamics, ocean worlds, cryovolcanoes, organic chemistry, and the evolution of planetary systems, all within a single destination. Very few places in the solar system offer such diversity. The Cassini mission finally came to an end on September 15, 2017. After 13 years orbiting Saturn, the spacecraft was running low on fuel. Mission controllers faced an important decision. Leaving Cassini drifting through the Saturn system carried a risk. One day, the spacecraft might accidentally crash into Enceladus or Titan. If either moon harbored conditions suitable for life, scientists didn't want to contaminate them with microbes carried from Earth. So they made one final choice. Cassini would sacrifice itself. The spacecraft performed a series of daring dives between Saturn and its rings before entering the planet's atmosphere for the last time. As friction built around the spacecraft, its instruments continued transmitting data until the very end. Then, the signal disappeared. Cassini became part of Saturn itself. Even in its final moments, the mission continued gathering scientific information. It was one of the most successful planetary missions ever conducted, and its discoveries continue shaping research today. Perhaps that's the greatest lesson Saturn has taught us. When Galileo first looked through a small telescope, he believed he had discovered a planet with mysterious handles. For centuries later, we've explored its atmosphere, measured the age of its rings, landed on one moon, flown through the icy plumes of another, and discovered worlds that may one day answer one of humanity's oldest questions. Yet Saturn still refuses to surrender all of its secrets. There are oceans we haven't reached, storms we don't fully understand, moons that continue surprising us, and questions that future generations of spacecraft will one day attempt to answer. Saturn is often remembered as the most beautiful planet in the solar system. But beauty was never its greatest achievement. Its greatest achievement was changing the way we think about planets. It showed us that a single world can possess an entire family of remarkable environments, that moons can be just as fascinating as planets, and that the search for life may lead us to places we once overlooked entirely. The more we learn about Saturn, the less it resembles a distant gas giant, and the more it feels like a gateway to understanding how diverse our universe can truly be. For thousands of years, Saturn was simply a bright light wandering across the night sky. Today, it's a reminder that even the worlds we think we know best can still surprise us. And somewhere beyond Saturn, beyond Neptune, beyond the edge of our solar system, countless other planetary systems are waiting, each with worlds of their own, each with stories we have yet to discover. Our journey through Saturn may be ending, but our exploration of the universe has only just begun.